This is a companion video to a blog about Crossplane and Kubernetes provider. Link will be down in the description. The intention of this video is to give you a guided tour of this Katacoda scenario, so you have a little bit better understanding of why we use Crossplane, Kubernetes provider, and what benefits do they give. I'm not going to go in detail through every link and explaining everything, but rather just make sure that you're familiar with the Katacoda itself and you understand what is the intent of the workshop. First, let's start by prerequisites. So it would be great if you're already looking at Crossplane, you're interested, you might have read a little bit about it. You definitely are familiar with some Kubernetes concepts. You are familiar with kubectl, Kubernetes CLI, and just are ready to explore Crossplane and its various options on your own. You might not want to install stuff on your computer, or you might be behind a corporate network that doesn't allow it. So this scenario is a perfect way to do some learning about Crossplane in an interactive way. So first page here, there are some goals of the scenario. I'm showing a little bit of Crossplane architecture. This is my attempt to dissect Crossplane components, but you can find much more in the Crossplane docs or on the Abound Cloud docs. I also prepared a short presentation. This is on slides.com. So if you're interested in just having a quick glance at what Crossplane is and what it does in a nutshell, this is a good place to start. All right, so when you start a scenario, it comes with the pre-installed components that will help us get started quickly. So this particular scenario comes with pre-installed K3s, which is a Kubernetes distribution from Rancher, and that is very small and fast to install. We have Helm, Crossplane itself, Crossplane CLI, Kubernetes provider, and Octant, which is a VMware observability tool. All right, so it looks like everything is installed. Let's make sure that our pods are up and running. All right, completed, running. Here is our Crossplane Airbag Manager and the Crossplane pod itself. Cluster seems to be healthy, version 1.22. And here you can always look at Octant while you go through the exercises, and you can see the whole cluster and explore various CRDs and Kubernetes objects. All right. So first, the scenario talks about Kubernetes provider itself, and I'm not going to go through the details. A lot of this is described already in the blog, but in a nutshell, provider is actually bundling together Crossplane CRDs or resources that are thematically specific to one thing, in this case Kubernetes. So Crossplane has its own workflow and philosophy, and we are going to use Kubernetes provider to show some of those things, because Crossplane is typically used in conjunction with cloud providers. So you could provision infrastructure like RDS, EC2, S3 bucket, or Azure Identity Provider. And this is obviously not safe using public infrastructure. That's why we're using Kubernetes as an example. Right, so this is the practical part. Whenever you can see this black square, whenever you click on it, then the command will be executed in the terminal. So what we're doing now, we are making sure that Kubernetes is aware of Crossplane definition and composition. Those are building blocks of Crossplane, which you can learn about from the documentation, but they define what do we want to happen when somebody is asking us to create a specific resource. In this case, this resource looks like this YAML. We have something called app claim. We have metadata, spec, composition selector, and then parameters. You can think about this YAML as a interface or API. So you have a relatively inexperienced development team that might not know a lot about Kubernetes, but they still want to be able to create applications and manage them themselves. And at the other hand, you have platform team that is Kubernetes experts. They know exactly what goes into a deployment, what security setting needs to be triggered, and other complicated Kubernetes resources. So that's the philosophy that Crossplane follows. At one hand, you have developers that can use claims that are really a simplified interfaces or APIs to infrastructure that is described by platform team, DevOps, SREs, however you want to call them in your company. But those are people that actually define infrastructure and expose simplified APIs to developers. All right, so let's click through. We are creating definition, composition. We can actually see whether our definition is up. So XRT stands for definition. It is established and offered. And we can see our composition. And you can see here, there's a composition called app frontend. All right. Now, in order to install our app claim, which will in turn create all the Kubernetes resources that I mentioned before, which is deployment, horizontal pod autoscaler, and service, we need to create a namespace for our team. It's exactly the same namespace as here. And now we can apply this file. So this file is just a few lines of YAML, but what's happening behind the scenes, when we apply this file, Kubernetes provider has its own controller running inside of Kubernetes. It's actually saw this file, and it's based on the definition and composition that we're going to look later. It says, aha, somebody wants to create an app claim. So if somebody wants to create app claim, I will spin up those additional Kubernetes resources. So you can see here, we have a bunch of managed resources. So we have like managed deployment, service, and ingress. So if I go to deployments, so kubectl get deployments in all the namespaces, we can see that in DevOps team, we have a deployment called Acme platform with 2 pods or 2 replicas. We didn't specify that we want a deployment, but because of the fact that this simple app claim rather tells Crossplane to create those resources behind the scene, those resources are defined in a composition, we have effectively created a deployment. The same would be with services. So kubectl get SVC, and also in the DevOps team, we have an Acme platform service that again was created as a response of creating this simple composition. So this is actually a clear screen right real quick. This is a web app, so we can actually see if it's deployed. If it's already deployed, means that Kubernetes pulled this image from Docker Hub, and then we can, in this case, port forward to it. I could use a service, but because of the limitations of Katacoda, it's much easier to port forward, and you can see the web page. It's the Kubernetes demo v1 with a really aggressive green background. Now, if, let's say, developers want to modify the service by upgrading to new version, in this case we are imagining we are upgrading to version 2 with a blue background, it's nothing simpler than just applying the same file which we've seen before, but instead of having this demo green, we will have a demo blue. There's nothing else needed. They don't need to change services, they don't need to change deployments. Everything will be adjusted accordingly behind the scenes by the Kubernetes Crossplane provider. So we have applied this new blue definition. We need to wait a little bit until the image is being pulled, and then we should be able to navigate to a page and by port forwarding to the same deployment, but this time it should actually be blue. So let's give it a try. Indeed, we have Kubernetes demo v2 with a nice blue color. All right, deleting the resource, it's as simple as delete. When we delete our app claim resource, it will delete in turn all the underlying resources. So we don't need to worry about cleaning up our cluster. So this is deleted. Now let's look a little bit what makes it possible. And Crossplane has a lot of very interesting components, but one that stands out by far is composition. Composition is a Crossplane construct that enables us to define what should happen, or to be more precise, what resources should be created or managed as a response to creating a claim or a composite resource. So think about compositions is something that platform team will take care of. So this is a complexity that does not go away. There's no magic delete complexity button, but it's now very neatly taken care of by a platform team or ops or DevOps, whereas developers have this very simple API YAML that contains resources and settings only that developers are interested in. So composition composes together a set of managed resources. It references credentials needed for accessing the API. In this case, we are applying our Kubernetes provider to the same cluster, but it's also possible and more likely in the production scenario to actually apply the resources into a remote Kubernetes cluster. So composition has two important concepts. One is for provider and another is patches. Those are actually sections of composition YAML file. For provider contains all the settings and all the specific resources in the case of Kubernetes that are going to be created for this particular provider. And the provider that we are using here is Kubernetes provider. So we are using Kubernetes, we are using Crossplane to manage Kubernetes. Now you can see here that we have things like deployment. So that's where it's specified within the composition. And it already creates liveliness probes, readiness probes, and resource limits, something we haven't specified. And typically developers have, it's challenging to know exactly what should I specify. Now, composition also contains something which is called patches. You can think about patches as an ability to map data from this simple file that we've seen in this step, appclaim. We have parameter namespace and image, and those values are patched accordingly to our composition resources. So I'm using patch here, and I am taking a spec ID and I am changing it to metadata name and applying some transformation. So patches are a really powerful way of applying, so taking value from one side, transforming it if necessary, and applying it to either composition or vice versa. Bidirectional patching is also possible. So you can think about a scenario here, for example. We can say our developers don't need to know the exact values for the CPU and memory limits as well as requests, but we could create a field that would say something like memory intense app or CPU intense. And if developers would put this parameter, you can imagine that there's a third field saying, memory intense app true or something like that, then as a response, the platform team could increase the memory limit to 500. And this field would be patched from the resource. So what this does, and why is it so powerful, specifically it addresses the problem of a common lowest denominator. Every team, every situation, every project will be slightly different. A lot of things will be the same, a lot of things will be standard, but there will be some differences, and it's very hard to account for those differences within most well-known projects that that are within the infrastructure as code or infrastructure as data space. Crossplane is unique in this regard that it enables platform teams or DevOps teams to build a targeted, customized compositions that completely encompass all the needs of development teams, and those needs can be different within a single company, which is an extremely powerful construct. Now, as you can see, this file is relatively lengthy, and it's also abbreviated, so in reality it's even longer. And this is something that I really like about the solution, because Crossplane does not pretend that complexity doesn't exist. It exists, and it will exist, and it will also likely grow as you embrace more technologies and your Kubernetes installation becomes more complex, or your cloud infrastructure becomes more complex. But this complexity is managed centrally within the platform team. So it's managed by a dedicated team that specializes in this type of things, and then exposed to developers via very easy and friendly interfaces within the YAML files, as we've seen before. So there are a lot more to Crossplane than just compositions, and Crossplane solves complex problems. In and of itself, Crossplane architecture is challenging to understand, but it's worthwhile. And if you're considering deploying something to cloud and managing it on the long run, or using other providers, like I'm showing here, Kubernetes provider, Crossplane gives you a lot out of the box, which doesn't really exist anywhere else. All right, let's go and continue. So key takeaways: Crossplane enables composable infrastructure, and this composable infrastructure is fully customizable from team to team, from project to project. It fully enables self-service and kind of follows the shift left movement. Developers can create and manage their own infrastructure in the simplistic files, and they don't have to open any tickets or ask anyone for permission. It highly increases automation. Crossplane plays very nice within GitOps solutions, things like Flux or Argo CD. I have blogged recently about Crossplane and Flux. You can read it, find it in my blogs, also in the description of this video. It standardizes collaboration between teams and platform team, and I would go even further and say that it standardizes the communication. So if you have a meeting where developers say, hey, this particular field is important to me, I would like to be able to select those settings, then after the meeting, platform team guys can go, create a new composition, and expose this field with these particular settings to developers. It's almost like, capturing the communication that happens and standardizing it instantly within the contract of compositions and claims. And it also provides or builds on top of ubiquitous language that is Kubernetes resources. So that's the whole scenario. You can click on the commands, as I've shown you before. You can type kubectl commands. This is a fully autonomous environment. Please do not put any personal or sensitive information here. This environment will be destroyed after about an hour, I believe. And you can always repeat the same scenario and learn. So, as I mentioned at the beginning, you can go to Upbound Cloud, and in Upbound Cloud, you can create your profile, sign in, and create your cluster real quick within Upbound Cloud, so you don't have to install anything locally, and you can try whether Kubernetes provider or maybe one of the cloud providers on your own for free with the guidance from the Upbound team. Now there's a bunch of additional resources. I mentioned other providers, so Helm provider is one of the other providers, which we also used, by the way, here. You can go to Upbound registry, and Upbound registry has a lot of configurations that you can try. So those are things like providers, which would be, AWS, in this case, provider Rook, Azure, Alibaba, GCP. So those are kind of official outbound supported providers. And you have also configurations, which is like starter packs that you can play with. So for example, you have a platform reference Azure, platform reference AWS, and it will enable you creating resources in AWS based off of compositions and definition already as part of this configuration. I highly encourage you to read this blog by Nick Cope, one of Outbound chief architect. I don't exactly know the right title, but he is behind architecting most of the current solution. You can read his blog, Crossplane versus Terraform, if you're familiar with Terraform. And also a very interesting blog by Bassam, which is a Crossplane CEO and founder, talking about Kubernetes API. And again, my blogs, one of them, I've blogged recently about why I believe Crossplane is the next big shift in infrastructure as code. And of course, Outbound has also a Slack channel. You can join Slack, say hi, and ask any questions there. All right, so that's it. Thank you, and see you in next video.